Now we'll learn about quantities. Scalar and vector. Scalar and vector. So there is basically two main important things in this. A scalar quantity. What do you understand by a scalar quantity? So a scalar like is a quantity which has only magnitude. Only magnitude. Here it will have magnitude. So both are having magnitude. This also has magnitude. Vector quantity this also has magnitude. But as I have told you in the previous sometime before that, what is the main difference between distance and displacement? Distance, what? There is no direction. So scalar quantity, there is no direction in this. There is no direction. It's irrespective of the direction. It can go anywhere from point A to point B, point C, point haphazardly. It can go anywhere. There is no direction as such. But if you take this vector quantity, there is a particular direction in this. There is a particular direction in this. So it has both. It consists of both magnitude and direction. It has only magnitude, but it does not have any direction. It does not has any direction. It has only magnitude, but it has not have any direction. It has both magnitude and it has its vector quantity. Therefore, we say that displacement is a vector quantity. So, what is distance? Distance is a scalar quantity. So, what is distance? Distance is a scalar quantity. Distance जो है वो क्या है? Distance एक scalar quantity है, क्योंकि इसमें आपको magnitude तो है, but no डायरेक्शन. इसमें आपको डायरेक्शन नहीं है. इसमें क्या है? आपको displacement is a vector quantity. Displacement is a vector quantity because it has both magnitude as well as direction. It has both magnitude as well as direction. This is a very important difference between distance and displacement. This is the second most important difference between distance and displacement. The first one being that distance can never be equal to 0, whereas displacement can be equal to 0. I will write it down here. Distance can never be equal to 0, whereas if you go for a displacement can be equal to 0. I have told you how the displacement can be equal to 0. So now you might arise with a question here that, so everything is fine, magnitude, direction, everything is fine, distance has no direction, displacement has both magnitude as well as direction. Distance can never be equal to 0, as you have told with an example. Then we have got it that how the distance can never be equal to 0. This also we have got it that how displacement can be equal to 0, because we start from the if we start from a certain point and if we end our journey at the same point, then the displacement becomes equal to 0. But sir, I didn't understand what is the meaning of magnitude here. What is magnitude here? So I'll tell you what is magnitude. So magnitude is nothing but it is like, depending upon the scenario or depending upon the occasions, depending upon the various factors. So magnitude can be like, it can be the size of the object or the body. It can be the speed of the object or the body. It can be the speed of the object or the body, or it can be any quantity of the object or the body. So if someone asks you, it's fine. You have told that direction is a scalar quantity which has only magnitude and which has no direction. That distance is a scalar quantity which has only magnitude but no direction. But can you explain me what is magnitude? So this is what is magnitude here. Okay, this seems to many of them as a jargon that what is magnitude, but this is what is magnitude. Magnitude can be the size of the object or the body. It can be the speed of the object or the body, or it can be any of the quantities of the object or the body, which can be defined at a particular time where it is used. And it is defined at a particular time where it is used. So now I think it's clear, very much clear to you what is the difference between distance What is the difference between the scalar quantity and the vector quantity? It has only magnitude, no direction. It's both magnitude and direction. And distance always comes as a scalar quantity because it has no direction. Displacement is a vector quantity because it has both magnitude and the direction. Because what is displacement? Displacement is the shortest part that is covered between any 2 points. Whereas distance is not the shortest part. It can be any haphazard part that is covered between any 2 points or any 5 points, any n number of points, or it can also even be infinite. Like we say that parallel lines may meet at infinity. We never know, but we say that the parallel lines may meet at infinity. So similarly, and distance can never be equal to 0 and displacement can be equal to 0. Now, I think you all got familiar with this. I'll rub it off. Now the question arises that okay. So now the question is about the two different types of motions. As I have told you, we will be learning about the two different types of motions. What is that? Number one is the uniform motion. Number two is the non-uniform motion. So there are these two important topics: uniform motion and non-uniform. Before that, I will tell you what is the SI unit of. I will tell you what is the SI unit of. I will tell you what is the SI unit of distance, and what is the SI unit of displacement. Distance is in meters, same as the displacement, because this is also nothing but the amount of the area covered, but this is just the shortest part of the area covered, and this is the part of the area covered without any particular direction. So this is meters. If you go to higher units, it can be kilometers. If you go to even higher, it can be miles. This also can be kilometers in miles. We know that 1.6 kilometers. You need to learn this, that 1 mile is equal to 1.6 kilometers, and you know that 1 kilometer is equal to how much? 1000 meters. Okay. So the SI unit of distance is meters, SI unit of displacement also. This is displacement and this is distance. This is distance, this is displacement. I've written in short, is also meters. Okay. So now moving ahead, I'll tell you what is uniform and non-uniform motion. So basically, I think it will be easier if I differentiate between this. It will be easier for you to understand. Okay, it will be easier for you to understand. Uniform motion non-uniform motion. Okay, so now what is uniform motion? This, if you just listen to this word properly, the word itself says uniform. The word itself says uniform. That means what? It's regular, consistent. This is just the vice versa of this: irregular. Irregular, inconsistent. As you might have studied in your class 8, the chapter of light, that is reflection, you might have studied regular reflection, irregular reflection. So it's the word is very familiar. Like you all are very familiar with this word. Like you have studied regular reflection, irregular reflection, which takes up from a smooth surface, is a regular reflection, and the reflection which takes out from an uneven surface is irregular reflection. Similarly, we have uniform motion and non-uniform motion. What is uniform motion? It's a regular motion. That is the rate of change. That is uniform motion is the motion. That is the rate of change of the body. That is the speed of rate of change of the body is always equal to with respect to time. That is, I will show you with a graph. See, if I write here this and this. So this is time. x, this is distance y. Okay, so this will be the graph of a regular or a uniform motion. This is the graph of a uniform motion. It means that, how can we define it? If a body travels equal distance in equal interval of time, it is called as uniform motion. Suppose this is 1, 2, 3 and 4. This is all in hours. This distance in kilometers. Suppose this is 10, 20, 30 and 40. Okay. So this is in kilometers. So what? Here, 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 here. Okay, so first hour it has traveled 10 kilometers, second hour 20 kilometers, third hour 30 kilometers and fourth hour 40 kilometers. So what is this? A body is traveling equal distances in equal interval of time. That is, for the first hour its speed is 10 kilometers. For the second hour it travels 20 kilometers. So again, for the second hour it has again traveled a distance of 10 kilometers ahead. Again in the third hour again 10 kilometers ahead. Again in the fourth hour again 10 kilometers ahead. So what is the difference between these? It's always 10 kilometers. That is, there is a uniform difference. There is a uniform difference between the distance traveled by the car per hour. Let's see. In the first hour it's traveling 10 kilometers, in the second hour it's traveling 20 kilometers, in the third hour it's traveling 30 kilometers, in the fourth hour it's traveling 40. So if I tell you distance is equal to speed per unit time, so what is this? Per hour, sorry, if I tell you speed is equal to distance but a time, sorry for that, if I tell you speed is equal to distance but a time, speed becomes distance but a time. So distance, if I tell you how much, 10, time is 1 hour, so speed is 10 kilometers per hour. Again 20 divided by 2, again it's 10 kilometers per hour. So you will see that there is a uniformity in traveling the distance which is covered in equal interval of time. That is, equal amount of distance is covered in equal interval of time. But similarly, what happens with an irregular or a non-uniform motion, or you can say irregular motion? What happens to it? Let's see the graph of this. This is x, this is y, this is time, this is distance, this is say z, this is say z. See, if I put here 1, 2, 3, 4, 5, all these hours, this is in kilometers. If I put 10, 20, 30, 40. So if for the first hour it has travelled this much, second hour it has travelled, third hour it has travelled, in the fourth hour it has travelled. So what do we see here? In the first hour it has travelled distance of 10 kilometers. In the second hour it travels a distance of 25 kilometers. In the third hour we see that it's travelling a distance of say 30 kilometers. And in the fourth hour we can see that it's travelling a distance of 45 kilometers. So what's happening here? It's all uneven distribution of the distances with respect to time. That is, it's traveling unequal distances. That is, if a body travels unequal distance in equal interval of time, if a body travels unequal distance in equal interval of time, then it is said to be non-uniform motion. I think you might have got very much properly with the help of a diagram that what is a uniform motion and what is a non-uniform motion. So I think I should draw this now. I think you might have noted all these things. This is non-uniform motion. Also, this in a very layman language or in a simple language, it's irregular motion because they do not travel equal distances in equal interval of time. This is a regular motion or a uniform motion where it travels equal distances in equal interval of time. So now we'll discuss what happens to a body if it is falling freely. Does the body have a uniform motion or does the body have a non-uniform motion? Suppose if a body is under a free fall, if a body is under free fall, that is, if the body is left to drop, is under a free fall. Suppose this is the ground. So what is this motion? If a body is dropped from here, if a body is dropped from here, so will this body, say this is the object A, will be in uniform motion or non-uniform motion? You need to learn that when a body is made to fall under a free fall condition, it always has a non-uniform motion. A body under free fall, always has a non-uniform motion. Non-uniform motion. Why? Because you will come to study about this in the coming chapters. You have gravitation. In class 9th you also have a chapter known as gravitation. In that you will come to know that why does a body under free fall is under a non-uniform motion. What happens to this when the body is under a free fall? So when the body is under a free fall, its speed increases by 9.8 meter per second in every second. Its speed increases by 9.8 meter per second in every second. That is when the body is under a free fall. Suppose if I take this body and if I drop it here, so what will happen? In every second, the speed of the body will increase to 9.8 meter per second. Suppose this is the body, and suppose if I take the duster, this is the body, suppose this is the object in the duster. Now if I put it under free fall, what will happen? In every second under the free fall, what will happen? The speed of this will increase by 9.8 meter per second in every second. And so it is called as speed increases by this, and hence it is called as non-uniform motion. And so it is called as non-uniform motion. That is, a body under free fall is always under a non-uniform motion. That is, a body under free fall is in non-uniform motion. That is, the body under free fall is under the non-uniform motion. The very much important point after this is that non-uniform motion is also known as accelerated motion. Non-uniform motion is also known as accelerated motion. Non-uniform motion is also known as accelerated motion. That is, suppose if a body is under free fall like this, what happens? There is continuous increase in the acceleration of the body. In this chapter, we will also come to learn about what is acceleration. We will very soon learn about what is acceleration, what is speed, what is velocity, what is the difference between speed, velocity, acceleration. Are all these parameters such as the speed, velocity, or acceleration the same? So we will learn about all these things in the coming time. But what happens here is that a body that's non-uniform motion is also known as accelerated motion, because there is always continuous increase in the acceleration. Acceleration is nothing. You everyone might have seen a car there. There is an accelerator in the car. So you press. You put your leg on the accelerator. You press the pedal and the car starts moving. So what happens? The more you press the pedal, the more faster the car moves, and the more faster the car moves. So what is this? That is acceleration. So that is called as acceleration. That is acceleration. So what is So in a non-uniform motion, so always known as is accelerated motion, because it always goes on accelerating or increasing the speed. We'll also come to learn about what is acceleration, what is deceleration. We'll all learn about this in the coming days. So I think you'll be familiar about. You might be now very much familiar about all these things. That is, what is uniform motion, what is non-uniform motion, what is the difference between a uniform motion and non-uniform motion, as I have drawn the diagram and I have showed it to you. Now, body under free fall is always under a non-uniform motion. This is the diagram. Why? Because at every point in every second, its speed increases by 9.8 meter per second. This I may make it more eligible. That is 9.8 meter per second in every second. Therefore, a body under free fall is in non-uniform motion, and a non-uniform motion nothing but is also called as accelerated motion.